Hi, good evening.
Good evening.
Good evening, ma'am.
How are you guys?
Good evening.
How are you guys doing? All good? Are you able to follow the course? Able to watch the videos on time and all?
Yes, ma'am.
Good. Any concerns regarding anything with the course logistics? All right. Okay, so today, we can discuss topics related to week 7 and week 8. So, more or less, the topics, you know, circle around the Fourier series, right? So I hope, yeah, by the way, your assignment deadline got changed. So I
Yeah,
think
thank you, ma'am.
week 8 deadline was postponed to 31st July. We cannot postpone it more than that period because quiz is coming up, right? So quiz is on August 7th. So
Yeah, but
I
this is
think week 7 deadline is 28 June. Sorry, July, and the week 8 deadline is 31st July, which I think is a good thing to do. Okay, all right. So any questions regarding, so have you guys, got chance to go through the videos fully, and did you guys at least have a look at the assignment? Any difficulty in understanding these topics?
I'm still not fully done with the video.
Okay. Of week 7 or week 8?
Week 7.
Okay, all right.
In the week 6, some assignment questions were uh,
Mm.
slightly difficult.
Oh, week 6 itself you felt difficult. Let me look at the assignment questions. What did I give? I remember giving one assignment. I deliberately gave one of the assignments as easy assignment, but no, which one it was, which week. Ah, okay. Week 6. What is the difficulty you're facing? I mean, it's okay, right? So let me just run through the questions. If you have week 6, we can discuss the week 6 questions. Let me go one by one. At least I'll give some hints. Okay, maybe for week 7 and week 8 also I can give some hints so that you don't face more difficulty. So week 6
And week,
graded
week
assignment.
6, one question, the answer was not
Maybe I
given.
think 10th question, huh? Some
No, no,
question.
no.
Yeah, even I noticed 8th question, I think.
Yeah, maybe, yeah.
Yeah, I noticed that. We'll give extra mark to that. Sorry. I think it is x of t minus t naught.
Uh,
Satyam also wrote an email to me regarding that. We'll give, yeah, we'll check
okay.
that. Okay.
Okay.
So, week 6 graded assignment. Do you have any difficulty with the first question? First question is okay, right? So,
Yeah, first was okay.
x1 of t, if it has some length t1 and x2 of t is, is another signal with length t2. What I mean by length is the signal is defined over this period. So if two signals have length t1 and t2, the maximum length of the convoluted signal, x1 of t convoluted x2 of t, the maximum length that it can go is T1 plus T2. So this is something which is already available in your class notes. Okay, you can have a look at this. So this is the max length that the convoluted signal. Notice that the length of x1 convoluted with x2 of t is not t1 plus t2, but the maximum length it can take is t1 plus t2. It can be even, the length of the convoluted signal can even be shorter than this, but the maximum length it can take is t1 plus t2. Okay, and second one, I think things are okay, like we already discussed, right? So what did we discuss? Suppose if we are given an LTI system with some impulse response h of t, we know how to verify if the system is stable or not. And also there is another part. So for the second question, it is given that H2 of T is periodic signal. The question is when H of T is periodic, the question is the LTI system stable? This is something that is discussed in your class notes. You can go and refer to the notes. So if H of T is a periodic signal, whether the system is stable or not, that is something that is discussed in your class notes. So you can just refer to your class notes and videos for this, and you would be in a position to figure out the answer for this. So if you understand the class lectures and the notes properly, you go through them properly, I think first two questions are very straight from your class notes. Okay, and we have also seen for the later questions, third question to I think fifth question, third to sixth. So 3 to 6, I think we have already discussed. Suppose if the impulse response is given for an LTI system, we know how to check for the stability condition. We know how to check for the invertibility condition, right? We know how to check for the causality condition, whether it is causal or not. And yeah, we know also how to find the impulse response of the system, right? We know that y of t, the output of an LTI system, is x of t convoluted with h of t. So just by writing down the convolution function, so what is convolution? So this is also same as h of t convoluted with x of t. In other words, this is same as writing d tau from minus infinity to infinity or minus infinity to infinity h of tau x of t minus tau d tau. So yeah, you are given something in this form in your question, and from this you can identify what is the h function, and also based on the limits of the integration. So based on the limits of the integration and also h, comparing this with the output function that is given in your problem, one should be able to find what h of t function is, and that would be the impulse response of the system, right? So that is how you can solve 3 to 6 questions. And like when you go to the seventh question, again it is straightforward. You're given the
Here,
impulse.
one doubt I had was it says if the system is linear.
If the system is linear in the first question.
Yeah. So the linearity is just because it's an integral.
Which first question?
Third question. Sorry.
So let y. Okay, is the given system linear? Okay, all right. So the way you have to approach, I wanted to give you this question. So yeah, so way you have to go about this question is you have to solve it step by step. So in the third question, you're supposed to identify whether the given input output relation. So you're given an input output relation where y of t is the output and your x of x of t is the input. So this x is an input function. So you're given an input output relationship and you know how to identify for the linearity, right? How do we identify for the linearity? So when we transmit x1 of t into the system, you get y1 of t. When you transmit x2 of t to the system, you get y2 of t. And now you have to verify whether the linear combination of these two inputs, when you transmit this as an input to the system, will you get, so this is a big question mark, will you get the linear combination of the previous two outputs? If this is true, then the system is linear. Otherwise, not linear. Okay, so this is something that you have to verify. For the given relation, you have to write your y1 of t, which is integral minus infinity to t sine t minus tau x1 of tau d tau, and your y2 of t is integral minus infinity to t sine t minus tau x2 of tau d tau. Now when a x1 of t plus b x2 of t, let me call this x3 of t, okay? So when I pass this through the system, my output corresponding to x3 of t would be, which I call y3 of t, is minus infinity to t sine t minus tau x3 of tau d tau, where my x3 of tau is a x1 of tau plus b x2 of tau. Correct? Now verify if this is equal to a times y1 of t plus b times y2 of t. Verify this. I will leave this to you guys. If this is true, then the system is linear. If this is not true, then the system is not linear. Okay, so this is the first thing that you have to check for. And the second thing that you have to check for is, fourth question, is the given system time invariant? So how do you check for that? So when you pass x of t into the system, you get some output y of t. Now when you pass x of t minus delayed input into the system, you get some y1 of t. y1 of t is obtained by delaying the input to the system. Okay, and call y2 of t as the delayed output, which is y of t minus t naught. You delay the output and check if y1 of t, which is obtained by delaying the input, if this is equal to y2 of t, this is again a check. This is true, then the system is time invariant. This is not true, then the system is time variant. Okay, so these are the first steps to be verified. Once you verify this, once you know that the system is linear and time invariant, okay, also check for the causal condition. Okay, the way you can check, maybe you know, once you solve third and fourth questions, maybe you can try to attempt sixth question first. So if you know that the system is linear time invariant, you can right away find, okay, you don't even need to verify, you know, you don't even need this to see whether the system is causal or not, but in any case, if you, so you can either, so from whatever we learned in our earlier lectures, we know causal means output should only depend on current and past values of input. Okay, this is true, then the system is causal, otherwise it's not causal. Or if you had identified, if you had identified that the system is LTI system, and if you can also find the impulse response corresponding to the LTI system, you can verify the causal condition by checking if h of t is equal to 0 for t less than 0. If this is true, then the system is causal, otherwise not causal. Both ways are okay. Okay, you can check through both ways, nothing wrong. Okay, and if third and fourth question led you to find out that the system is LTI system, then the way you can solve the sixth question is, the output of the LTI system is x of t convoluted with h of t, and which can be written as minus infinity to infinity x of tau h of t minus tau d tau, and comparing this with the given signal or given system, in your assignment, one can find the impulse response h of t. Okay, so that is how you have to go with this question. Is that okay, Gayatri? So it's like
Okay.
step by step. So this is like some assignment problem. So you have to solve it step by step. Okay.
Okay. Thanks.
Yeah. And then, yeah. Mhm.
Ma'am, how to find h of t in question 6?
So, all right. So assignment deadline is over, right?
Yes, ma'am.
Okay. So the given output y of t is integral minus infinity to t sine t minus tau x of tau d tau, right? So this is like integral minus infinity to t x of tau sine of t minus tau d tau. So, comparing this with this, one thing you can definitely say is h of t is some sine t. But then you should also identify another point, that the limit exists only till t. So h of t is sine t until some value t, and after that it is uh, you're getting it right. So uh, the given signal, so the given thing is only defined until okay, so let me write this. So this can be written as minus infinity to infinity x of tau sine t minus tau correct, because what is u of t minus tau? U of t minus tau is 1 when t minus tau is greater than 0, which is, when tau is less than t, this is 1, otherwise this is 0, right? So the given output relation y of t can be written as, so this I am just converting, so this whatever I wrote here, I'm trying to convert it in form of star. My given signal has limits from minus infinity to t, but what I have here is minus infinity to infinity. So I'm just trying to, you know match the limits, right? Now star, and let me call this star star, are in the same form, and from this you can identify that this part of the signal corresponds to h of t minus tau. So if h of t minus tau is sine t minus tau times u of t minus tau, what would be h of t? H of t would be sine t u of t. So you have to at every step you have to think about what you need, and you have to go about it. So at this step, that this is the output of an LTI system when the impulse response is h of t. You are given this as your output of the LTI system. Now you have to identify what is h of t, and this is the given signal. You are trying to compare with what you know, and what is differing is the limits, and you try to make the limits match, and then you try to, so there are certain common parts which are, so this is the common part, and the other part is something that you would like to identify, from which you know that h of t minus tau is this, and from there you can identify the impulse response. Is that okay?
Yes, ma'am. And why you multiply u of t minus tau?
That's what I told you, right? So, what is the output when when x of t is transmitted into some LTI system with impulse response h of t? What is the output? The output is y of t. Y of t is simply the convolution between the input signal and the impulse response. And what is the definition of convolution? By definition, convolution is defined as x of tau h of t minus tau d tau over all values of tau. Correct? Are you with me?
Yes, ma'am.
And the given signal is defined only from minus infinity to t. So this is the output that was given to you. Okay. Now I want to compare these two. X of t is there in this, x of tau is there here, x of tau is there here. Sine of t minus tau is given here, h of t minus tau is given here. But if I want to make the comparison, everything should be similar, right? But the integral that is there over here, which is going from minus infinity to infinity, is not running over all values of tau. It is running only from minus infinity to t. So when I want to compare these two equations, the tau values on which the integration is running should also be same, right? So hence I want to make this integral to run from minus infinity to infinity. The only way that I can do that is I can use a step unit impulse function, right? Because you know that uh, unit step function, sorry. So you know that unit step function u of t takes value for all values 0, and it is 0 for all, sorry, t greater than 0, and it is 0 for all t less than or equal to 0. You know this. Now I want something to take value 1 until t prime is less than t, and it should take a value for t prime greater than t. So I am defining such a signal which is nothing but u of t minus t prime. So this is the signal which is defined like this. So hence, to make the integration match with the original definition that I know, I multiply with a u of t minus tau signal. These are all tricks you are supposed to learn from signals and systems course. Okay. They won't come right away, but you have to practice a lot to learn these tricks. So this is one of the reasons for you to do this course. These are certain tricks that will be used in later courses and which you should learn from the signals and systems course. Okay, you can think about it, work, practice writing this problem. If you are not able to get it, maybe write it down using a pen and paper couple of times, and then you will get it. Okay, is that okay?
Yes, ma'am.
Yeah. Yeah, these are certain tricks that how like maybe when we were children, while trying to learn addition, it would have been difficult for us, right? But over the time we learned it, practiced it, and now it's like we couldn't even think of something how one cannot do addition. So this is also something like that. These are certain tricks that you may have to learn from the signals and systems course, and which you may have to practice a lot to understand and remember them. Okay. So, all right. So this is with your which question? Sixth question, and moving to the seventh question. I think it is again pretty much simple. So, is the system given by the impulse response stable? Maybe uh, impulse response implies like the system is an LTI system. I forgot to mention that, but so maybe note it down. So for the seventh question, the system is an LTI system. I forgot to mention that explicitly. But you are given an impulse response. Now you have to identify whether the system is stable or not. We know how to do that. We just calculate the, so we just see if it is absolutely integrable, which implies we evaluate this particular term and see if this is less than infinity. If it is less than infinity, then it's stable. We studied this thing. And eighth question, yeah, there's a mistake in the answer. So when you do the convolution of these two signals, what you get is x of t minus t naught. It is also better if you guys, discuss among yourselves. If you don't understand anything, it's good to have a discussion among yourselves too. Okay. And ninth question is pretty much simple, right? It's just the property, it's the distributivity property of convolution, right? So it's just direct. So it uses couple of properties, convolution satisfies distributivity and associativity. So have to use those couple of properties to do that. And as regards to 10th question is a very nice exercise for you to solve. So y of t is given as f of t convoluted with g of t. And now the question is, what is the convolution of f of t minus g of t minus t2? I'll tell you the answer. So this is y of t minus t1 plus t2. Okay. So yeah, this is another interesting property. I think sir has given this in your class notes. If not, it just uses direct properties of whatever we learned. You can maybe call this function as some so this as some f1 of t, and this as some g1 of t. And what is f1 of t convoluted with g1 of t? That is simply f1 of tau g1 of t minus tau d tau, right? Now what is f1 of tau? F1 of tau is f of tau minus t1. What is g1 of t minus tau? That is g of t minus tau minus t2 d tau. So when you simplify this, I mean when you take the right variables and try to simplify this, what you get is y of t minus t1 plus t2. Just have to, you know, uh, take the variables and integrate this over the right parts. I don't want to do this. I explicitly didn't give you the solutions because I would like to encourage interactions among you guys. So try to discuss among you. So it's just solving this integration. Pretty much straightforward. You have to, take the right variables and try to do it. Okay. You can discuss this among yourselves. Straightforward from here. You still have doubts, you can email me. Okay. And 11th question, yeah, it just uses this property. I wanted you guys to, have a flavor of using this property. So in one of our earlier assignments, we saw that u of t convoluted with u of t is the ramp function r of t. This is something that we saw in our earlier, I think in week 5 assignment. If you had solved week 5 last question, u of t convoluted with u of t is the ramp signal r of t. This is like a constant thing that everybody knows. And likewise, del of t convoluted with del of t is again del of t. And any function x of t convoluted with del of t is also x of t. Because of that reason, u of t convoluted with delta function is again unit function. Okay, so these are certain things which you should be, like they are straightforward things which you should remember. So u of t convoluted with u of t is r of t, which we already solved in our earlier assignment. So u of t convoluted u of t is r of t. So this is like f of t, this is like g of t, this is like y of t. So you have f of t convoluted with g of t as y of t. Now the question is, so we know that convolution is distributive, hence this simplifies to u of t plus 1 convoluted with u of t minus 3, right, minus u of t minus 2 convoluted with u of t minus 3, right. Now this is like f of t minus t1 convoluted with g of t minus t2, where t1 is equal to minus 1, t2 is equal to 3. So what is this from our earlier property? That is f of t minus t1 plus t2, which is y of t minus 2. And what is our y? Y is the ramp signal. So this part is r of t minus 2. Correct? Likewise, when you try to solve this part, that would be r of t minus 5. Right? So you just have to apply the 10th question property for the 11th question to see this happen. Okay? Is that okay?
Yes, ma'am.
So this assignment is pretty much clear right now.
Yes, ma'am.
Okay. So I think practice assignment also, had the similar setup. So if you look at the 10th question from practice assignment, week 6 practice assignment, 10th question, it again uses the same property, whatever we just saw. Okay. So it is u of t convoluted with u of t minus 2. U of t convoluted with u of t is r of t. And this is like shifted version. You know how to solve it now. Okay. And going to the 9th question. So you're supposed to find the output of an LTI system, for which, so the impulse response of an LTI system, h of t, is given. And the input to the LTI system x of t is also given, which is u of t. This is e power minus t by 2 u of t. Now you're supposed to find the output. What is the output of an LTI system? Output of an LTI system is the convolution of input with the impulse response h of t, which is simply the input u of t convoluted with the signal e power minus t by 2 u of t. And we know how to do the convolution. How do we do? So this is minus infinity to infinity u of tau e power minus t minus tau by 2 u of t minus tau d tau. And this is simply minus infinity 0 to infinity e power minus t minus tau by 2 u of t minus tau d tau. So u of t minus tau is 1 only for tau less than t. This is 0 for tau greater than t. Hence this is simply, you can calculate from here, hopefully. You can evaluate this integration. Okay, what happens? So I want to show one thing to you. So when you evaluate this, what happens to this? I mean, if you want to evaluate this integral, so this is definitely 0 when t is less than 0. So this integration exists only when t is greater than 0. And when t is greater than 0, what happens to this? So this is e power minus t by 2 uh, by minus 1 by 2 minus e power tau by 2 divided by sorry, e power minus t by 2 divided by minus 1 by 2, and this is 0 by minus 1 by 2 sorry, with respect to tau, right? So this is plus 1 by 2. Correct me if I'm doing some calculations. So this is minus e power minus t by 2 by 1 by 2. So which implies that this is 2 times 1 minus e power minus t by 2 when t is greater than 0. In other words, you can write this as, if you multiply this with u of t, this is what you get. So when you have something, when you have some x1 of t which is defined as some function f of t when t is greater than 0 and 0 for t less than 0, then you can define x1 of t as f of t multiplied with u of t. This is another trick that you can, use. Okay, is that okay?
Yes, ma'am. But
Hmm.
I have confusion in where you change the limit from minus infinity to
Hmm?
how you change
Confused.
the infinite limit from minus infinity to 0 to infinity
Oh, no,
in
no,
second
no. I
equation.
didn't change the limit. So I have two signals. So this is my x of tau and this is my h of t minus tau. My x of tau is u of tau. U of tau is 1 until tau greater than 0. For all tau less than 0, this is 0. So for all negative values in tau, you are actually multiplying with a 0 signal. So there is a, so I didn't change the limit, but the other part of the limit went to 0. Is that okay? So this whole thing went to 0.
Yes, ma'am. Oh, I got it.
Okay, so you have to work this down, Satyam. So rigorous working is needed. So yeah, if you guys are not, very comfortable with the assignment problems, you guys are going to have a hard time with the quiz problems. So you need to work it out really hard. Also, please have discussions among, your teammates. I think in week 8 we gave couple of practice questions which can trigger some discussion among you. So please kindly discuss, verify your answers with others. Maybe if you aren't able to solve, some other person will be in a situation to solve the problem. Have discussions, have online meetings among yourselves. Learn the convolution operator properly. Okay. So otherwise it will be very difficult in the later part of the course. Okay. So all right. Next, going to 8th, 7th, And sixth, I think it's pretty much again the same. So eighth question is about checking the time invariant property for the given impulse function. H of t is equal to e power minus t by 2 u of t. Okay. And seventh question is you have to check. So yeah, so you have to check if the given system is linear. And sixth question, you have to check if the system is causal. Fifth question, check for the stability. Fourth question, check for the causal condition. Third question, we already discussed it in one of the live sessions, right? So whether the differentiator operator is a memory system or memoryless system. So this is something we already discussed in our previous live sessions. So this is a memory system because dx of t by dt can be written as x of t plus limit epsilon tending to 0 x of t plus epsilon minus x of t by epsilon. So this is actually depending on other values of input other than the current value. Hence, the system carries memory. This is something that we discussed in our earlier live sessions. So I wanted to again, remind that to you. And second question is again pretty much simple. And for the first question, yeah, you just have to use the property that we discussed earlier. Okay. So yeah, this is what it is. I hope week 6 is clear now. Yeah.
Yes, ma'am.
Okay. So yeah, week 6 is okay. So let me also just quickly go through week 7 questions. If you are facing any difficulty with the question, let me give some hints now itself. Okay. Week 7. So week 7 graded assignment. Okay. So yeah, since I found few people are not able to catch up with the speed of the course, I wanted to give or let some students at least learn the formulas properly. So first question is pretty much straightforward. We know that. So you have to verify whether the given statement is correct or not. So the statement states only the periodic signals have Fourier series representation. Aperiodic signals cannot be written in the Fourier series representation form. So that's the statement given. You have to verify whether it is true or false. If you guys understood where Fourier series is coming from, if you have understood the complete lecture uh, notes of the Fourier series, you should be able to answer the first question. It's pretty much straightforward. Okay. Second question, it's just the representation of the Fourier series. You have to verify whether that is true or not. Even that is pretty much straightforward. Nothing like you don't even need to spend like more than 10 seconds on these questions. And third question, yeah, you have to verify whether the given convolution is true or not. So it's just the definition of convolution. You have to check if the convolution definition is correct or not. Okay. So 1, 2, 3 questions will not take more than 30 seconds for you to solve. And fourth question, so there's some signal x of t that was given and you're supposed to identify the fundamental time period of the signal. We know for any sinusoidal signal of this form, fundamental frequency or for that matter any cos signal of this form, fundamental frequency is given by f. Fundamental time period is given by 1 by f. Fundamental angular frequency is given by we learned all these things already, so you should be comfortable. Okay, so given we have this question also will not take you more than 10 seconds to solve, right? Fifth question. So x of t is given as sine 10 pi t plus pi by 6. Now you are supposed to identify the Fourier series coefficient a0. There are two ways to do this. Okay, it's always better to go with the standard way. The standard way is, what is the formula for a0? 1 by t minus t by 2 to t by 2 x of t dt. You have to evaluate this to find a0, right? And what is your t? T is the fundamental time period. That is the reason why the previous question came in the first place. So in order to find fifth question, you should know fourth question answer. Okay, you have to identify the fundamental time period from fourth question. Identify the fundamental time period and try to evaluate this integral. So this is one way to solve. Or the other way is, suppose if you are given some general signal sine 2 pi ft plus 5, or which in other words can also be omega t plus 5. Okay, so this signal can be written as e power j omega t plus 5 plus e power minus correct, which can also be written as okay. So this is in the form of some constants multiplied with the exponential signals, right? So what do we know about the Fourier series representation? Every periodic signal can be written as Fourier series in the form e power minus ak e power j k omega t. Okay, so try to write this in form of this, and also try to identify what omega is, and from which you can identify the Fourier coefficients a0, a1, a2 and all by comparing the coefficients here. Okay, for example, in this case, if I am leaving omega as omega, then a0 is 0, a1 is e power j 5 by 2, a minus 1 is e power minus j 5 by 2, and ak is 0 for all k not equal to 1 or minus 1. Okay, so any signal that is in the form of sine and cosine can always be written as exponential signal, and from exponential signal you can always compare with the standard form and try to identify the Fourier coefficients directly, even without evaluating such a tough integral thing. Okay, is that okay? Is that okay?
Yes,
ma'am.
Yeah, so this is like a simple thing to do. So if you see some sine or cosine signal which you know is always periodic, instead of trying to evaluate using this tough integration thing, you can always write it in terms of exponential and just compare it with the standard form that you already know. Okay, so okay, given now you have this, I think fifth question, sixth question, seventh question, and eighth question, ninth question. So everything is just straightforward. 5 to 9, everything you can solve, right? And just now the 10th question, this is something that is directly from the notes. Yeah. So yeah, given these hints, this assignment should not take you more than 10 minutes to solve, right?
Yeah, for you it will be 10 minutes now.
Oh, still it'll take more time, huh?
I'm worried about quiz 2 already.
Yeah, the course depth will, yeah, the course gets really deeper now. Yeah, you guys need to practice a lot. Okay, you still feel this assignment to be difficult, huh?
No, I haven't yet completed the lectures, so I can't come.
Okay, so try to again go through the hints before solving the assignment if you are facing some difficulty. They are pretty much straightforward questions. Okay, and yeah, assignment 7 is like uh, these assignments are very simple. So you should not face any difficulty in solving assignment 7 questions. If you are facing some difficulty with this, then you guys need to practice a lot, otherwise quiz will be really hard. Okay. Okay, all right. So let me go through week 7 practice assignment. So first question is pretty much straightforward from the notes. Second question is also straightforward from the notes. I think first to 4 questions they're just straightforward from the notes. As in, like, if x of t has Fourier coefficients ak, then what are the Fourier coefficients of x of minus t? So these things are already discussed in your notes. You can go and check them. And fifth question, x of t is 1 plus sine 2 pi t. Very nice. So this is in the form of sinusoidal signal and we know how to write this. So this is e power j 2 pi t plus e power minus j 2 pi t by 2. Identify what is the fundamental angular frequency omega, and then try to write this in form of 1 plus e power j omega t plus e power minus j omega t, some factor a1, some factor a2 by 2, and then try to find the Fourier coefficients. Okay, so that is how you have to go about this. So any sinusoidal signal that is given to you, it is very easy to calculate the Fourier coefficients, because for any periodic signal, the Fourier coefficients are in the form k, ak, e power j, k omega t. Try to write whatever the sum you are seeing here in this form. For example, 1 can be written as 1 times e power j 0 omega t. Okay, so from this you can readily identify that a0 is 1. Okay, plus the other part is e power j 2 pi t. Even before doing that, you have to identify what omega is. So f is 1 here, so t is also 1. So your omega is 2 pi by t, which is 2 pi. So 2 pi is the omega. So I can write this as e power j omega t plus 1 by 2 e power minus j omega t. In other words, I can write this entire thing as 1 times e power 0 omega t plus half e power j 1 omega t plus half e power j minus 1 omega t. Now compare this with the form a0 e power 0 omega t plus a1 e power j1 omega t plus a2 e power j 2 omega t plus and so on, and on the a minus 1 e power j minus 1 omega t plus and so on. This is what the Fourier series representation is, right? For any periodic signal x of t. So comparing these two, so this is also your x of t. Comparing these two, one can identify that a0 is 1, a1 is half, a minus 1 is half, and ak for all k not equal to 0, 1 minus 1 is simply 0. Okay. So if you're given any sinusoidal signal or cosine signal, it is always easy to identify the Fourier coefficients. There is no difficulty at all. So I did it for 1 plus sine 2 pi t. You can do it for, so the next question 7, 8, 9, 10. They are given on the signal 1 plus cos 2 pi t. Sorry, sine 2 pi t, you have to correct me. So sine 2 pi t is e power j 2 pi t minus e power minus j 2 pi t by 2j, right? So you should have corrected me. Okay. So a1 is okay. Now, yeah, you can go and do it for 1 plus cos 2 pi t. Write it in terms of exponentials and try to compare it with the Fourier coefficients. Okay. So that is all is there in your practice assignments. So practice assignment 7 and graded assignment 7 are very simple. So they shouldn't take you a longer time. You can work this out since yeah. So should I also give hints for week 8 today itself, or should we discuss it in the Saturday's session? So what do you
Later,
want?
ma'am.
Hmm?
Saturday.
Saturday? Okay. And do you want me to discuss any particular topics? Are you facing any difficulty with understanding Fourier series or something?
Right now, I don't know, ma'am. Saturday, we'll discuss.
Okay, all right. So you guys should be very comfortable with doing the Fourier series things. Please watch your lecture videos. Please go through live sessions if you are facing any difficulty with solving the questions. So in this live session, we discussed both week 6 and 7 assignments. If you are facing any difficulty with solving week 7 assignments, go through this live session and then go and solve the assignment questions. Okay, they are not very hard.
Okay, ma'am.
Hello.
Yes,
Hello.
Prabhanjan. Yeah.
This professor is using presentation during session. Can you share that presentation also in supplementary content?
Let me check with the professor if that is allowed. We'll definitely share. Okay.
And it will help us to revise quickly because at last moment you are not able to go through that. Yeah.
Okay. But also, Prabhanchan, like you guys should take the notes. Okay, while you are watching the lectures,
Yeah.
you guys should take the notes. We at times deliberately do not upload the notes because it should always be a practice for students to take class notes. Okay.
Yeah, we
So
are doing
if
it, but
we,
sometimes it's
yeah.
become easy to refer. No? Yeah.
If you take the notes, it shouldn't be right because already the videos, you can just go. So if you make a nice class notes by yourself, I think you shouldn't be in a. It shouldn't be a problem. So try to take your notes. I'll also check with the professor if the slides can be shared, and then we'll let you know. Okay.
Yeah, no problem.
But don't be very hopeful. We want students to take the class notes. Okay.
Yeah.
All right. So I'll take leave for today. But please go through these topics and let us discuss more on these topics on Saturday. as well as in the other 2 live sessions next week. Quiz is coming up on August 7th. If you understand your, yeah. Huh?
On 4th, no?
Is it on 4th or 7th?
4, ma'am. 4
Oh,
August.
it's 4th for you. Oh, I thought it was 7th. Okay. Quiz is coming up on 4th. It's pretty quick. So we have 3 live sessions before the quiz. So 28th we can discuss on week 8, and if you have any questions regarding Fourier series and all, we can discuss on Saturday. I could have done that, but since you guys did not go through the lecture videos, I would like to do it on Saturday. And next week, 7th, and maybe it's better, sorry, not 7th, 31st, maybe it's better if I prepone the 3rd live session to some other day, no? Since 4th. So do you want me to conduct live session on 3rd, or do you want me to prepone it since your exam is on 4th?
And prepone it because on Saturday we have to travel.
So when will it be better for you guys?
Friday.
One day
Thursday,
earlier.
Friday?
Just one day earlier.
Yes, on Friday.
Friday. Okay, what time would be comfortable for you?
Evening even, same time, 8 to 10.
8 to 10. Okay, we'll have it then on Friday 8 to 10. Okay. All right. Yeah.
No, the Friday 8 to 10, it clashes with maths, I think.
Yeah, check that and one of you let me know. Okay.
Yeah, okay.
All right. So I'll take break for today. Please go and finish off watching your lecture videos and solving the assignments. Okay. Yeah. Right. We'll upload this video.
Thanks a lot.
Yeah.
Thanks,
Thank
ma'am.
you. Yeah. Bye.
Thank you, ma'am.
Yeah. Thank you. Bye. Good night.
Good night.
Satyam, you had some other doubts, right? So can you
No, ma'am.
your doubts are cleared? So
Yes,
your
yes.
assign. Okay. All right. Yeah. Thank you, Satyam. Yeah. Bye.